Hi, my name is Nur Amirahani binti Muhammad Yusof and my matrix number is CF230049. In this presentation, I will explain an introduction of our project which is focused on analyzing the impact of heavy rainfall in Hulu Terengganu, assessing the capacity of the Kenyir Reservoir under extreme condition. So let's start with the problem statement. During the monsoon season, Hulu Terengganu experiences frequent and heavy rainfall which has become an irregular concerning phenomenon for local authorities and communities. Recent data from DID Department of Irrigation and Drainage at Kenyir indicates that the rainfall levels in the area have significantly increased compared to previous years. As the heavy downpours continue, meteorologists and hydrologists have emphasized the need to assess the reservoir's ability to handle extreme conditions. This is vital because Kenyir Reservoir plays a crucial role in mitigating downstream flooding, and any failure to accommodate the excessive rainfall could have severe consequences. Hence, it is essential to evaluate the reservoir capacity under this condition to ensure it continues to function as a safeguard against flooding. Based on the issue identified in the problem statement, my study has two key objectives. First, to calculate the total rainfall over a specific time period using Simpson's rule. This mathematical method will allow us to accurately estimate the cumulative rainfall using available data. Second, to estimate the volume of water that Kenyir Reservoir can hold based on the rainfall calculations. The Kenyir Reservoir isn't just a body of water, but it's a lifeline for the community in Kenyir. It's where the people get their water, it supports livelihood like fishing and farming, and it even attracts tourists with its natural beauty. But since it was built in 1985, the reservoir has faced growing challenges. The changing season brings heavy rains and floods, as well as dry spells that threaten water supplies. This fluctuation affects people's daily lives, like fishermen struggles with income, farmers deal with water shortage, and the local tourism industry is impacted too. So, to make things more complicated, climate change has made the weather even less predictable. Floods are getting worse and droughts are lasting longer. This is why it is important to study rainfall patterns and come up with practical solutions like better flood warnings, improved irrigation, and sustainable ways to manage water. At its core, the Kenyir Reservoir isn't just a resource, it's a part of the community's identity and future. Okay, so now I will proceed for filler table. So for the first row, for the fact, we collected rainfall data every 1 day for a total of 6 days. So the data we get from the ID page. And the idea is we applied Simpson's rule to figure out the total rainfall over this period. And the learning is Simpson's rules is used to approximate the area beneath a curve, and in this context it reflects the amount of rainfall over a period. And the application, this lets us determine how much water could possibly fill a reservoir when it rains. Okay, for the row number 2, the amount of rain is given in mm per day for each period. So the idea we comes out is that rain can be turned into water volume by taking the reservoir size into account. For the learning, rainfall data help us to figure out how much water is collected as long as we know the surface of the reservoirs. For application, this is beneficial that water resources as the design of reservoirs of the forecasting of water levels. For the third row, for so for the third row, for the F, the reservoir possesses a defined surface which plays a crucial role in influencing the volume of water it can accumulate. For the I, estimating rainfall and correlating it with reservoir surface allows for a clearer understanding of water volume being stored. And for the L, the integration of rainfall data and surface area enables to make well-informed choice regarding water management and storage. And for the application, this can assist in forecasting future water requirements, in controlling flooding during periods of intense rainfall. For the last row, the Simpson's rule is effective for data points that are evenly spaced, as is the case with hour-day interval. And for the I, the precision of the result relies on how good the rainfall data is and whether the intervals are consistent. And for L, learning, comprehending the application of integration methods such as Simpson's rules can facilitate the simplification of calculation. For the last one, it's a smart approach to transform raw data into useful insights for managing water in the real world.
Assalamualaikum, my name is Ariani binti Azmi. My matrix number CF230216. So my part is literature review and also the methodology. So for the literature review is firstly trapezoidal rules. The trapezoidal rules is a method for estimating the area under the curve by dividing it into trapezoid instead of rectangle. It calculates by area by average the value at the left and right end of each interval. This method is useful for problems in heat transfer, fluid flow, and structure analysis. While easy to use, it is less accurate for smooth curves compared to Simpson rules, which use a quadratic approximation for better precision. The trapezoid rules rely on a linear approximation, making it simpler but less precise. Next is the Simpson 1/3 rules. So Simpson rules originate from the works of Thomas Simpson, an 18th century mathematician who developed the method of inches by accuracy of numerical integration compared to simpler approach like the trapezoidal rule. By utilizing quadratic interpolation, Simpson introduced a more precise way to approximate integral, establishing a foundation for the widespread use in scientific and engineering application. In the Simpson 1/3 rules, the minimum segment is 2, where the trapezium rules is a 1. We accrue an area 1 which is n is 2 segment under Simpson 1/3 rule by applying Newton forward difference up to the second order. So the third one is Simpson 3/8 rules. The Simpson 3/8 rule is a method of numerical integration created by Thomas Simpson in the 18th century. It is also called Simpson's second rule and improved on one limitation of Simpson 1/3 rules. Unlike the 1/3 rule, which is use quadratic interpolation, the 3/8 rules use cubic interpolation. It approximates the function fs over 3 subintervals. The interval AB is divided into the NN equation equal part where NN must be divisible by 3. This rule provides another way to estimate integral with good accuracy. So the methodology is firstly we do the discussion on civil engineering related topic So the next we do the filler table about our problem. After we got the problem in related of civil engineering, and then we do a brief description of the method and the problem, and then we do the some study of the method employed. After that, we determine which is method can solve our problem statement. After we got the method, we do the calculate the solution to the problem, and then lastly we do discussion and conclusion for our problem.
Hi, my name is Nuraja binti Sulaiman. My metric number is CF230210. Today I would love to talk about our calculation in our mathematics project. As you can see, this is our data that we collect from GPS website. It has a rainfall, total rainfall, daily rainfall from 10 January to 15 January at Kenyir, Hulu Terengganu. This is a graph that daily rainfall versus day. The method we use in this problem is a Simpson rules. We try with the Simpson 1/3 rules, and then we get the volume is 63.3573 times 10 power of 6 meter cube. This is the volume that the water that collected in a reservoir in 5 days. In 6 days. For using these rules, we need to find the F naught, Fn, F odd, and F even. First of all, I find the H first. The interval is 1, and then we plot the table, and we get that for F first, for F naught and F left 6. For F odd is 109, and for F even is 36.5, and then we just put into the formula H/3 bracket F naught plus Fn plus 4 times F odd, and then plus 2 times F even, and then we get the total rainfall is 171.667 mm, and then we convert it to meter for us to calculate the volume. To calculate the volume of the water that collected in the reservoir for 6 days, so that we able to predict if something irregular happen. Okay, for the next step is we use Simpson 3/8 rule so that we can compare which one is more accurate, whether it will get a big difference or not. So for the Simpson 3/8 rules, we get for the F naught and F plus is 6. For F, that not time by 3 is 115.5. For F, that time by 3 is 30, because the number that in F time by 3 is only Y3. That is 30. And then we get the total rainfall is 0.1547, and we calculate the volume, and then the volume is 57.0843 times 10 power of 6. So this is the water that were collected in the water reservoir for 6 days. This study, for the discussion, this study's analysis data daily rainfall trend in a Kenyir reservoir area for 10 to 15 January using a GPS data. We use a Simpson 1/3 rules and the 3/8 rules that were used to estimate total rainfall and reservoir volume. Okay, the rainfall range are from 0 to 79 mm per day. Using Simpson 1/3 rule, The total rainfall were estimated at 171.667 with a reservoir volume of 63.3573 times 10 power of 6. When we use Simpson third rule, the result we get is slightly lowest, which is 154.688 mm, and the rainfall for the rainfall and 57.0843 times 10 power of 6 volume of the water. This study showed that these mathematical tools help in managing water resources from planning, flood control and water supply. Adding more data and improving method could make future calculation even more accurate. That's all from me. Thank you.
So, in conclusion, this study emphasizes the importance of numerical tools in studying rainfall patterns and their impact on the Kunyi Reservoir. Rainfall fluctuated greatly over the 6 days investigated, and Simpson's 1/3 and 3/8 rules provided insight into total rainfall and reservoir volume respectively. The study found that while both procedures are reliable, the result may differ slightly depending on the integration methodology utilized. Lastly, this study highlights how crucial it is to integrate environmental research with mathematical techniques in order to provide sustainable water management and a better standard of living for those who depend on these resources. That's all from our group. Thank you very much.